Okay, I'm going to go ahead and get started. Hello, everyone. Thank you so much for having me. My name is Molly, and I'm a program manager on Microsoft Edge. Today, I'm going to be talking about how Microsoft Edge is working towards building a world without passwords. As the internet becomes more ingrained in our everyday activities, people struggle to maintain password security across multiple accounts and devices. This, of course, contributes to the rise of cybercrime. The most fascinating part about it is that this is almost entirely avoidable. People just favor convenience over security. One of the factors that contributes to this is weak credentials. I think we all know this, but password complexity is very important. We've kind of seen this massive push towards password complexity. Yet, in the year 2016, the most common password on the internet is still actually the word password. Another thing that users are guilty of is reusing passwords across multiple sites. The average user doesn't stop to actually think how incredibly risky this is. One compromised database could potentially be a user's entire network of accounts. And this doesn't just go for users. Database admins also potentially could make really weak databases, and as a result, forget to hash passwords, something small like that. So I think the worst part about all of this is that even though some of us use best practices and we try really hard, somewhere down the line, someone's poor decision could actually cost us. So Kevin Mitnick once said people are prone to taking mental shortcuts. He also said people are likely to be tempted, pressured, or intimidated into giving away information. I'm going to imagine that Kevin Mitnick, being one of the most famous social engineers in the world, probably has a pretty good idea about this. So I think we can establish that passwords are obviously the weakest link in authentication. This is especially dangerous because people take mental shortcuts or they can't be trusted with secure information. So the question is, how do we actually eliminate passwords from the equation? Sorry. So the concerns around passwords have been around for a long time. The reality is that when we think about authentication, we think about passwords. So one group actually emerged that had the goal to create passwordless authentication, along with bringing together all the security devices, such as fingerprint readers or USBs, and creating an interoperable experience amongst them. Some of the people in this group include Google, PayPal, Microsoft. There's over 200 representatives in the FIDO Alliance. They may sound familiar to you. It's because they actually host the U2F protocol. That's where you can actually use two-factor authentication and use a USB security device. YubiKey is kind of the most famous one that you can see out there. So the U2F protocol was actually developed by Google and Yubico. Microsoft chose actually not to support this functionality and instead chose to support the FIDO 2.0 credential specification, which was later submitted to the W3C. As you can see, I think I cut it off, but Mozilla, PayPal, Google are all contributors of the specification, but Microsoft is actually the only browser currently that supports it. So what does it actually look like to have a passwordless experience? The client will make a request to the server to authenticate. The server will send down a challenge. That challenge will be signed by a private key that was previously provisioned. The signed challenge will be sent back to the server. That challenge will actually be verified with a public key that was the pair to the private key that signed the challenge. And then that information is returned, and the user is now able to authenticate. So before I get started, I want to make sure that I'm very clear about which party is doing which. So when I refer to the client, I'm going to use it as an umbrella term for browser and platform. I will specify if it's really important, and then I will make it very clear when I'm actually referring to the user. With the relying party, we have the server and the website, and again, it's going to be an umbrella term. The reason I want to specify, or I want to point out, is that the relying party isn't necessarily always referring to the website or the server. In situations where you're using a third-party authenticator, that would actually be the relying party, whereas it wouldn't be necessarily the website. Okay, so because we're the only browser that actually support this API, I'm going to only refer to Microsoft technology. In the future, it could be expanded to other devices such as USBs. But for now, it's just going to be the actual Windows Hello experience. Has anyone actually ever tried Windows Hello? A few people? Awesome, okay. So with Windows Hello, you have this thing called gestures. It's what's actually used to verify the identity of the user. So things like PIN, fingerprint, facial recognition, and iris scan. Once the user has been verified with Windows Hello, it will unlock the TPM, which is a dedicated piece of hardware used to create and protect credentials. If there was one thing I want to kind of make clear by the end of this presentation is this idea, because this is kind of the overall idea of the Web Authentication API. So you have one user, someone's biometrics or something they know, one device, which would be a security device. In our case, it's Windows Hello, and then one account. Just to kind of be clear and make that more obvious, Molly's device, so this is my security device, and I have two accounts, a work email and a personal email, all from the same domain, so I'm actually going to have two credentials there. If I had two security devices, it would again be two credentials. Okay, so let's take a look at what traditional password authentication actually looks like. I think we all kind of understand the general idea of it. I input a password, the password is salted, hashed, compared against a whole database of passwords, and then we found one user is allowed access. So we have quite a few vulnerabilities in the current model. We have attacks from social engineering, giving away your information, phishing, key logging, privilege elevation, and then also, like I said, not hashing passwords. And then let's take a look at how this actually looks with the passwordless model. So with social engineering, we don't actually have a password that we input. Nothing is sent across that is actually should be kept secret. So we don't have social engineering. Same with pretty much all of these. And then from the server side, there is no databases. Nothing is really stored that's secret. The only thing that really we have is a public key, and as we know, public keys can be shared. Okay, so I've talked kind of a little bit about the security aspect of it. I'm going to go ahead and show a demo and show you guys what the actual experience is like. Okay, so I'm going to use a puppy cam. I figured if my demo exploded, I would at least have a puppy to fall back on. Okay, so I'm going to register using my Windows Hello account. I will be prompted. It actually went really fast, but it recognized me. And now I'm going to go ahead and I'm authenticated. So we have this little video of a puppy. I'm going to take a drink of water while he hangs out. Okay, so the Web Authentication API. It actually has two methods, make credential, which we can think of as registering a user, and get assertion, which is authenticating a user. Oh, sorry, I'm in the wrong mode. There we go, okay. Okay, so this is an overview of registering a user. The most important thing is that the site will have to serve the page over HTTPS. So the user will request to use passwordless authentication. The very first thing that's picked up by the browser is a check to make sure that the browser does in fact support the Web Authentication API. If it doesn't, the developer needs to make sure that they write code that reverts back to the legacy authentication that they had previously. Okay, the make credential call is made. This is actually what the method looks like. So it's wrapped in a promise. The promise is going to be resolved when the new credential is sent back to the server. Within that credential information, it's just going to be a public key and a credential ID. And then finally, there is a catch in case the user hasn't actually set up the Windows Hello authentication system, or they decide they don't actually want to use this process when authenticating. The very first thing that we have is information about the user. So this information will be used later on for situations like an account picker. So if you're trying to authenticate to a domain that you have multiple accounts on, this information will be used. It was collected when the user actually registered, either with the Windows Hello experience or previously just with a normal password. A big question I get a lot is about the image URL. This is just a path to the profile photo that was previously decided for the user. Like in social media, it's going to be your profile photo. The next thing that we have are the crypto parameters. So the type is always going to be scope credential. It just means that it's per origin. And then the algorithm is information about the property of the credential that's going to be created on the client side. Another thing to note is that these are actually in order of priority. So if the client doesn't support one of these algorithms, then it can revert back to the next one in line. And then finally, we have a challenge. This is one of two challenges. There's going to be one challenge for registering a user and one challenge for authenticating a user. This one is to verify that the client does in fact have the proper system to create credentials. So it's actually called an attestation challenge, and it's going to be signed in our case by the root key in our TPM. Okay, and then finally we have options. The options are optional. It just kind of adds constraints to, it allows the developer to add constraints. So it would be things like timeout seconds refer to how long the relying party is willing to wait for the developer to return the call. And then we have exclude lists, which avoids multiple credentials being made from the same account on the same authenticator. So all that information is sent down. The very first thing that's going to happen is there's going to be a platform prompt for the client. It's required with Windows Hello that you have to register your Windows Hello account to your machine first. We do this to verify the identity of the user. If you didn't have Windows Hello in the future, it could be something like two-factor authentication, whatever the case may be, however you want to decide to actually implement it. And then as a side note, this prompt is actually generated by the platform. It's not generated by the browser. So things like ad blockers are not going to be blocking this prompt. Okay, and then with generating a credential, the first thing is you're prompted for your biometric. In this case, it's a fingerprint. Windows Hello will verify the identity of the user. At that point, it will unlock the TPM. The TPM will create a private and public key pair. At the same time, an attestation challenge will be signed by the TPM, and all of this information will be sent back to the server. The public key, the credential ID, and the attestation statement. So again, overviewing, this is actually how it runs through. And now the user is registered with the passwordless authentication. Okay, so this is how it looks if you have multiple accounts. You're going to have a separate private key and public key for each of them. It's an important thing to note. I don't want anyone to get confused about that, but okay. And then overviewing for authenticating a user. So a user will request to be authenticated, returning to the site. This is an overview of what the actual method looks like. So the method, like the make credential, is wrapped in a promise. It is resolved when an assertion is sent back from the client. And then it is, there's of course a catch if the user doesn't have the correct hardware set up or they've rejected to use this form of authentication. And then here's our second challenge. So this challenge is used to, of course, assert that the user is in fact who they say they are. A new challenge is generated each time it comes from the server, and it is used to avoid replay attacks. And then just like make credential, we have options. So timeout seconds to specify how long you want the call to take, and we have an allow list. The allow list is useful for a couple of interesting corner cases, which I'm going to go into. So in the future, when it's possible to have mobile authentication, like a USB, The allow list can be used to actually handle the situation where a user has a Windows Hello machine and a USB plugged into their machine to try to authenticate. This particular part of the specification allows developers to choose which credential they prefer. So let's pretend like credential 1 was generated from my Windows Hello machine. The other was generated from a security USB device. So I can actually specify I prefer it to be generated from a TPM versus a USB security device. And it's an order of preference right here at the bottom. So this is what the user experience can actually look like. You can have just a login button, and that's it. No input for username. So what will happen in this case is that an allow list will be sent over, and it will be completely empty. From there, once it's received on the client's platform, the platform will go through and find all credentials associated with this domain. And it will look something like this. So let's say I had 2 accounts with Outlook. It will actually pull up all my Outlook accounts. I can choose which one I want. Now I can use that to authenticate in. And this information, again, comes from the make credential call and all the account information associated with it. Now, the next experience we can have is logging in with a username. So I can log in my username. From there, the database is indexed, the credential ID is sent forward, and now I can start authenticating using that account. So the relying party will send down the challenge to the authenticator. I will be prompted. I'm first asked if I want to continue with this experience. If I am, then from there I'm authenticated in. And this is actually what it looks like when you're signing the challenge. So there's a lot of data that actually goes into the signature. One part is the authenticator will actually generate code. And that's one of the objects that's used with the signature. Additionally, you have client data, which is a combination of relying party data and client data. And then appended to that is actually the signature that is sent down. That is hashed, and then the two are appended together. The private key that was previously provisioned will sign it, and that will go across, and now we have the signature going to the relying party. That signature will be verified with the public key that we previously provisioned. Sorry, some water. And this is what the overall experience will feel like. Okay, so what's next? What is currently available? What is coming? So right now we have an experimental version. It came out with the Windows Anniversary Edition. You can go ahead, play with that, mess around with it, see how you like the experience. It does come from a much earlier version of the Web Authentication API. So we have a polyfill available that will give you a very similar experience to what it would be like using the spec now. However, with the new release of Windows, we're building it to spec, and you can actually build an experience from that you can implement in your sites. Fourth, I would just recommend reading the spec. It's very interesting. There's a lot of corner cases about authentication I never thought I would think about, so it's kind of fascinating. And then finally, because I work on Edge and I think we have a bunch of really great resources, I'm just going to point you guys to some of those. One is that we have a blog. It's really awesome. It's going to be the best place to actually look for information on the Web Authentication API and all of our new releases with it. The next one we have is status. I think this is one of the best resources we actually have available on our website. You can, if there's any specification that you're interested to see if we support, you can actually type it in here and it will let you know if it's supported, in development, deprecated, as well as a very slight roadmap to what other browser vendors are doing as well. And then finally, we have an issue tracker. So this was released just a couple months ago. Sorry. And it's a really great, seamless solution for developers and users alike to actually submit bugs. I think one of the most amazing parts about it is that it actually opens up a dialogue with the developer who is fixing your bug for you. So you can write them comments and they can write you comments back. So it makes things a lot clearer. It's really nice. I think that's it. Okay. Does anybody have any questions?
Tell us more about the USB keys that you were talking about.
Yeah, so in the future, I'm assuming that there will be USBs that will be available. There is none that are available right now for the Web Authentication API. Like I mentioned, U2F has those security USB devices, like the YubiKeys. I'm imagining in the future something like that will be available for the Web Authentication API. I have no idea. It seems like a good market to start jumping on. So.
So you're relying on the existing, say, facial recognition system or something like that. None of that data gets passed through. Is that how it works?
Yeah, it's all on your local machine. So all authentication is happening on the client's machine. Yeah.
So how does it integrate with other websites, like Google or like my Gmail or like my bank account?
Sorry, could you say that just a little bit louder?
How does this authentication integrate with existing websites?
So it just depends if the website decides to implement the Web Authentication API.
And if they do, then they have to, what do they have to do?
So you can read the spec. If you're interested in actually applying it, you can read over the spec and then from there go through the code and figure out how to do it from there. There is a few guides available online. I'm sure we'll release one once we actually release with the next version of Windows, but.
As a web API, is it tied to the particular hardware platform of Windows Hello? Or is it more general?
No, it's more general than that. Our support of the Web Authentication API is tied directly to Windows, but it depends on however the browser vendor decides to implement it.
Is there any ETA for other browsers implementation?
I don't know. I mean, all I can say is on the W3C, you can see who's contributing to it, so at least there's interest, but I have no idea about actual dates.
With regards to the key store is just on that one machine.
Yep.
So if I have multiple machines that I need to move with, how am I going to transfer the keys between them?
So you don't ever transfer the keys. You're going to have to register a new device each time. That was my point about the one user, one device, one account. So you're always going to have to create that bond each time that you change any of the factors in there.
So, but are you going to be able to establish that it's me every time?
As
Because are you going to uniquely identify me as an individual, or are you going to just assert that that was a previous guy that logged into this?
So with what we have available right now from Windows, the Web Authentication API is the only thing that we support. And when you're actually registering, they make you verify that you are in fact the account owner. So it's always going to use that verification. So if you were to use your phone and your computer, they're all Windows. Each time you're going to be logging into your Windows account. So from there, they'll be able to verify that it's you across accounts and devices.
In which other ways are you going to be able to authenticate? Is it just going to be through photo or like printer scanner, fingerprint scanner, or are there going to be different ways to authenticate?
Yeah, so right now we currently support facial recognition. You said photo. It's not actually a photo. Just to make that clear, a lot of people are worried about that. You can't just hold up a photo of yourself and log in. No. So facial recognition, iris, fingerprint, and then a PIN. So we have those 4 available right now. I don't know what people will decide to support in the future, but. Yep. You can. I think you can clear the TPM. I don't know too much about that scenario, but if you did that and removed the credentials somehow, you would have to re-register yourself completely. Yep.
Can you do the iris recognition with a standard webcam?
No. So anything that involves biometrics except for a fingerprint is going to be a special camera that they have inside of few different machines. It's like an Intel RealSense, and that's the actual camera that can do that. Fingerprint, I mean, I have an old Lenovo machine, and I can use my fingerprint, so I'm pretty sure as long as it's a fingerprint reader and has Windows 10 on it. Yep.
What's special about RealSense? What is different than a normal web?
I don't know too much about the details of that. I know there's a lot of documentation online. If you're interested, if you message me on Twitter, I can get you something.
And it gets depth as well. So the risk factor is if you were to get a 3D printout of your actual head, then potentially that has been used in some edge cases, but someone has to really want to emulate you.
Yeah. As far as I know, I just know that it takes depth perception and then uses that to create a template, and then from there, that's kind of where my knowledge is limited about biometrics. Any more questions? Yes.
So if someone were to have an existing application that had, password support, from experimentation, like how much effort is it to integrate the additional support for this API to start exposing it? Like how much code would they have to write? How much time are we seeing in the folks who are piling in early?
Well, I just showed you guys the API. So it's only 2 methods. It's fairly easy. I think if you're using actual Windows Hello, I mean, that is pretty much what I just showed you. Of course, we have an experimental version and a polyfill, so it's not going to be the full experience, but overall implementation is fairly easy. There's not too much going on. There's pretty much just, make a credential and get an assertion, and that is the experience. A lot of your legacy code will fall back really nicely with this process as well. So if you're worried about users not having the support already, it's very easy to just, well, try this then.
So how do you validate that assertion? Do you send that to your server-side code and figure something out around it?
Yeah, so it's verified with the public key that was created when you make a credential.
So do you keep that public key in your server-side code and then?
Yeah, it's going to be stored in a database usually, along with the credential ID, which is used to identify it, as well as other information you would want to have about that user. Yep.
What are some of the fringe cases that you're talking about?
Oh, what was that?
What were some of the fringe cases that you...
So I think the only time I talked about edge cases was around the allow list. So I think edge cases maybe wasn't quite the right word. I just meant the different variations of user experience you can have. So you can have just a login button, and from there you'd use the allow list to actually pull out all credentials that are possible. Otherwise, you can use the allow list for verifying what kind of actual authenticator you want to use. Cool. If there's any more questions, I guess ask me now. Otherwise, ask me on Twitter. Yep.
Just one more.
Yeah, no worries.
Microsoft intended to support this method to authenticate yourself in a real organization, like in your real domain.
Oh, you mean like enterprise?
Yeah, like the enterprise.
There is some documentation about Windows Hello in enterprise. I don't work on that field or know very much about it, but again, if you want, just follow up with me. I can send you some information. All right, cool. Thank you guys so much. I really appreciate your time.